When the Challenger broke apart in the sky, not everything disappeared in that moment. One part of the spacecraft remained intact. The crew cabin, the place where the 7 astronauts were, it separated and continued in the air for a few seconds before beginning to fall. What happened to the crew? You think you know what happened to the Challenger? But there is a part of this story that is almost never shown. January 28, 1986, Cape Canaveral, Florida. The explosion in the sky is broadcast live, watched by millions. It is estimated that around 40% of the United States population was watching in real time. Classrooms across the country followed every second. This was not just another launch, it was a national event. Challenger was part of a fleet, a system that represented a new era of space exploration. The Space Shuttle program had an ambitious promise to make access to space more frequent, more efficient, almost routine. And up to that point, it seemed to be working. Challenger had already completed an impressive record: 995 orbits around Earth, more than 41 million kilometers traveled, nearly 1,500 hours in space, successful missions, complex operations executed with precision. It was not experimental, it was considered reliable, and it was not alone. Other shuttles in the fleet operated alongside it, reinforcing the idea of a stable system. But there was an important detail. This program operated under constant pressure. Launches were frequently delayed, not as an exception, but as part of the process. Technical issues appeared, adjustments were needed, and countdowns were stopped, sometimes just minutes before liftoff. Challenger itself had been delayed multiple times, and this created consequences. Every delay meant cost, millions of dollars, schedule changes, mission adjustments. But there was something even greater. Pressure. Public pressure, political pressure, internal pressure. At that moment, the United States was ahead in the space race. Maintaining that position was essential. The space shuttle represented more than technology. It represented national pride, one of the most complex machines ever built. And that pride also influenced decisions. It had been nearly 20 years since the United States had experienced a fatal accident in a crewed space mission. This history created a perception: safety, control, reliability. But there was a side effect: overconfidence. Because the more a system works, the harder it becomes to see its limits. Over time, small warning signs began to appear. Nothing alarming at first, but enough to raise questions, and those questions were not always treated with urgency. At the same time, the space program itself was evolving. After the Apollo missions, NASA was looking for a new direction. One of those directions was to bring space closer to the public, to make it more human, more accessible. That is when the idea of sending civilians to space emerged, and on that mission, it became reality. A teacher, Krista McAuliffe. Alongside her were Commander Francis Scobie and pilot Michael Smith, and completing the crew, Ellison Onizuka, Judith Resnick, Ronald McNair, and Gregory Jarvis. 7 people, 7 lives, all on board that day. This increased attention and also responsibility. But while the public saw inspiration, inside the system there were doubts, and those doubts would intensify just hours before launch. On the night of January 27, 1986, a meeting was called. This was not routine, it was concern. On the other end were engineers, managers, specialists, teams from NASA, and the company responsible for the boosters. The issue was clear: temperature. It would be one of the coldest launch mornings ever recorded for that type of mission, and that changed everything, because there was a critical component affected by the cold, a small element, almost invisible to the public, but essential to the system. Its role was to seal the joints of the solid rocket boosters, preventing extremely hot gases from escaping. If it worked, the system remained stable. If it failed, there would be no control. This was not a new issue. Over the years, there had been warning signs, erosion, wear, signs that the component was not performing as expected. Nothing had caused a disaster, but the problem had never been fully resolved. That night, engineers presented the data again. Reports, tests, past incidents. The concern was clear. In low temperatures, this component behaved differently. It could lose flexibility, it might not seal in time, and that created a window, small but critical. The recommendation was clear: do not launch, at least not under those conditions. But the final decision was not purely technical. It involved schedule pressure, delays, expectations, and perception of risk. Because nothing catastrophic had happened before, that absence of failure was interpreted as safety. The discussion shifted. The data was called inconclusive, and gradually, the decision changed. The launch was approved, even with doubts, even with warnings, even with known risk. And at that moment, the course of the mission was set. The next morning, January 28th, the launch proceeded. The weather was still cold. Ice was visible on the launch structure, but the countdown continued. From the outside, everything seemed normal. Millions watching, cameras live, classrooms following every second. Ignition, engines start, boosters ignite, Challenger lifts off. In the first seconds, everything appears stable. But less than a second after launch, the first signs appear. Small puffs of smoke, brief, intermittent, almost invisible, exactly where engineers had warned. But now, there was no turning back. The shuttle was already in flight. For a moment, everything seemed fine, as if the issue had resolved itself, but it had not. As altitude increased, forces grew, pressure built, the system responded differently. Around 60 seconds into flight, a new signal appeared, this time visible. A flame. It emerged from the same point, and it grew. Within seconds, it reached the external tank, and from that moment, recovery was impossible. Inside the cabin, there was no clear indication of what was happening. The crew continued their procedures. The last communication was transmitted. Everything seemed normal. Seconds later, the structure failed. Challenger broke apart. Not as a typical explosion, but as a structural breakup under extreme forces at about 14 kilometers of altitude. In an instant, the shuttle became multiple fragments, and among them, one remained recognizable: the crew cabin. It separated and continued its trajectory through the air before beginning its descent. After the breakup, debris fell into the ocean, but what happened was not immediately understood. There was confusion. The broadcast showed only the cloud in the sky. Recovery operations began. Ships, aircraft, divers. The debris field was vast. Pieces were recovered gradually. Until the crew cabin was located, it had remained structurally recognizable after separation. The most severe damage occurred on impact with the ocean, but what was found inside changed everything. Some emergency systems had been activated, not automatically, manually. Switches had been moved, systems engaged. This indicated human action after separation, attempts to respond, but there was no control, no procedure for that scenario, and no escape system during launch. The cabin followed a ballistic path for about 2 minutes and 45 seconds before impacting the ocean at over 300 kilometers per hour. The forces involved were extreme. Even after detailed investigation, the exact moment of death could not be determined. But some conclusions were possible. The breakup itself likely did not cause immediate death, and the manual actions suggested some level of response after that moment. Beyond that, no definitive answers. And that is one of the most uncomfortable aspects of this story. But the Challenger disaster was not just technical. It began with something simple: a piece of rubber, a sealing ring, a small component that cost only a few dollars but had a critical function: Under normal conditions, it sealed the booster joints, but in the cold, it failed, and that was enough to trigger the entire chain of events. The investigation revealed deeper issues, not just a failure, but a pattern. Warnings had been given, data existed, concerns were documented, but they were treated as acceptable risk. The decision to launch did not ignore missing information. It ignored existing evidence, and that changed everything. The disaster exposed failures in organizational culture, communication, and decision-making. Risk evaluation had to be redefined. The program was paused, systems redesigned, protocols changed, safety took a new priority, and the impact extended far beyond NASA. The Challenger case became a global study in engineering, management, and risk, a lesson in how complex systems fail and how small decisions accumulate. But there is another side to this story. The families of the crew continued the mission. They created educational programs, science centers, initiatives to inspire future generations. The mission that did not happen in space continued on Earth, reaching millions. In the end, Challenger is not just about failure. It is about a pattern. Small decisions, ignored signals, accumulated over time, because the greatest risks are not always the obvious ones, but the ones that seem too small to matter. Until they do. And maybe the real question is, how many decisions today seem safe until they are not? If you enjoy stories like this, stories that reveal how one small detail can start a domino effect that changes everything, subscribe and follow the details. Because the next story might be even more unbelievable. In history, the world doesn't change only because of big decisions. Sometimes, one overlooked detail changes everything.